Yo, what's up? It's your boy out here in Italy. Beautiful Amalfi coast. Been here for a few days visiting different towns. Rented a scooter as well. Get some nice coast drives. And wanted to do a question while I was out here dealing with grade 12 advanced functions. This is a popular question that comes up in the polynomial functions unit. You have probably seen it, and so I wanted to do another example for it. I have a bunch of examples on my website. I'm assuming you've watched those before watching this one. And in this particular question, what's happening is we have a 30 centimeter by 20 centimeter metal sheet. And what we're gonna do is we're gonna cut out squares from each of those corners and then fold it up to make a rectangular prism. And we're told that the rectangular prism is going to have a volume of 1056 centimeters cubed, and we have to figure out what's the length of the squares that we cut out. And so what we could do is we could label that as our variable, the length of the squares that we cut out, as x. And so what we have to do is come up with an equation somehow where we're going to be able to solve for that x value. So what we could do is try to label the three sides of the rectangular prism as certain expressions in terms of x. And so notice that if we looked at the length of the rectangular prism first, the initial length of the metal sheet was 30 centimeters. But notice that we took out a length x from each side, and so the remaining length, the one that's left over of the base after we fold up the flaps to make the rectangular prism, that's going to be 30 minus 2x, because we took out those two x values on the side. And then same thing with the width. Initially it was 20, took out those two x values, and after we fold it up, then the width of the base of the rectangular prism is going to be 20 minus 2x. And then the height is just going to be the length of the flaps, which is actually just the length of the squares, and that's just going to be x. And so we know that the volume of a rectangular prism is length times width times height. And so we could say that the three expressions for the sides of the rectangular prism all multiplied together is equal to that volume of 1056. And so notice that at this point you just have a polynomial equation to solve. And so you want to expand everything, bring everything over to one side and make the other side equal to 0, and you want to solve for the different x values. And so let's solve this with the factor theorem, try to get those different x values. And so what you want to do, because this is a cubic, it's not going to factor by grouping this particular one, you have to go through the factor theorem and do it by trial and error, trying different x values. But what's nice is because this is a word problem, and we let x represent the length of the squares, we know that x can't be negative. And so when you're doing the trial and error, you don't have to worry about testing -1, -2, etc., etc. You could just go into testing +1, +2, +3, etc., etc. And if you follow that process, x equals 4 is actually going to work. That's going to be one of the solutions. And that's actually a legit solution, because if we plug in that x value of 4 for the expression for the length and the width, we would get positive values there. We would get 22 and 12. And so one of the sets of solutions is going to be 4 by 22 by 12. And notice that if you multiply those, you would get that volume of 1056. However, we're not done there. You need to test if there's going to be other solutions as well. And so you have to finish the factoring process. Now, because x equals 4, was one of the x values that made this cubic function equal to 0, we know by the factor theorem that x minus 4 is a factor. So we could take that cubic function, we could go through the long division process of dividing it by x minus 4. Notice that when we do that, we would get a remainder of 0, which is expected. You should be getting a remainder of 0. If you don't, then you could go back and you know you made a mistake somewhere. However, we do get a remainder of 0, and we have a remaining quadratic there, quadratic to solve to see what x values make that quadratic equal to 0. Now this particular quadratic, it's actually not going to factor smoothly, and so you have to take that quadratic and put it through the quadratic formula. And when you put it through the formula, you're going to get two solutions, 3.8 and 17.1. Notice that 17.1 is not going to be a legit solution, because if we take that 17.1 and plug it into either the length or the width expression, we would get negative values there, and we can't have a negative length or width. So 17.1 we would ignore. However, the 3.8 is a legit solution, because when we plug an x value 3.8 for the length and the width, we get actual positive values for the length and the width of 22.4 and 12.4 respectively. And when you multiply those out, because we rounded a bit, the 3.8, it's not going to be exactly 1056, but it's going to be fairly close. If you didn't round the 3.8, if you maybe rounded it to like 4 decimal places, then the lengths are going to be more exact. I just rounded it to 1 decimal place. The biggest thing that I'm trying to point out is that you have to continue the process and test out other potential x values. You don't want to just stop if you get a legit solution before, like we did with the x equals 4. And so at this point, we are done. So there's actually 2 sets of solutions, 2 sets of dimensions, 4 by 12 by 22, and 3.8 by 12.4 by 22.4. And that is a wrap for the question. So if you want to see more videos like this, you can go to my website, allthingsmathematics.com. For the entire course, videos are organized by chapter, a bunch of tests you could try at the end of each unit as well. They got thinking questions, application, communication, knowledge, all that jazz. And if you feel like you need any personalized help, you can hit me up. Currently tutoring students all the time over Zoom, both high school and university. And so my contact details are on the website. Give me a shout whenever. I'm going to get back into exploring the coast, but I will catch you in the next one. Enjoy your day. Peace out. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.